Welcome to iotyantra Technologies. Hello viewers. In this present video, I am going to demonstrate the home automation project with the help of radio frequency communication. Here in this project, we have a switchboard which is custom made, which we have built, which contains a radio frequency RF 433 MHz receiver, and then ATmega 328p Arduino based microcontroller, and the oscillatory circuitry here, the 16 megahertz crystal 22 picofarad bypass capacitors, which are for oscillator, a reset button, and a pilot LED just to indicate the power, a barrel jack for feeding in the 5 volt DC power, filter capacitor, and there are 4 relays. You can see the 4 relays are operated on 5 volts, and there is a transistor buffer. Just a minute. There is a transistor buffer for each and every module. You can see here there is a BC547 transistor here. 4 such transistors are driving this particular relay setup, and there are buffer diodes and the flyback diodes. You say these are the flyback diodes. 4 diodes, 4001 and 4007 flyback diodes are used for protecting the transistor from the glitches produced by relay while turning off. And also there are some diodes which are connected to the base of this transistor only to protect the controller from any mishap. If at all anything is wrong for the relay, and if the transistor also breaks down, the reverse voltage may damage the controller. Controller is costly and we have to protect it. Transistor is okay, you can replace it, but if the controller is gone, you have to replace it. You have to spare several hundreds, right? So we have protected this transistor. We have protected the controller's output GPIO pins from any spikes by using this particular diode. So the current can flow, the voltage can flow from this side to this side. That is, the controller can give any signal to this transistor's base, but any backward glitches generated by this circuit cannot be fed back to the controller. So controller is now protected. So here 433 megahertz this RF receiver module is there. There is a whip style antenna. You can see there is a wire which is of about 17.2 centimeter long to support the reception of 433 megahertz radio frequency waves. So this is the basic setup, and this is the transmitter part. This is the receiver part. Of course, we have embedded everything inside a switch box to look like a compact product. So you can just close the screws. We can do it later. And the antenna is still visible outside, and there is a receiver, there is a transmitter also. Let me show you the other part. And one more thing, the relays output wires are coming out here. We are using 4 such relays. So these 2 are representing the 4. We will be marking it here, so we can put 1 2 3 4 etc. We know the marking. And the thick wire here shown here, this thick wire is the common phase. So you have to feed the common phase here, and the load side you have to feed it here in the real-time switchboard. So you can just replace this box. You can just place the box near the existing switchboard in order to have the automation process getting done without disturbing anything else. So you have to just fix the box near the original switchboard, and you have to bypass the loads through this. And coming to the transmitter part, let me keep it aside. So we have got another module here. So in this case, once again, we are having the same ATmega 328p as a transmitter, and you can see the crystal here. This is the crystal 16 megahertz and the supporting 22 picofarad capacitors, and these resistors, of course, this is for resetting the circuit. One resistor is used for resetting the circuit, and another one, this is 1K, is used for giving the pilot lamp. So you can see whether the power is available or not. And there is a regulator here. You can see this is the 7805 5 volt regulator. Of course, the transmitter is powered with a 9 volt battery. So this 9 volt battery is fed to, the positive side is fed to this 7805 regulator, and from there it gets reduced to 5 volts, and then it is connected to this microcontroller. So this acts like a receiver. And coming to the main component here, this controller is powered by, this controller is fed by the RF signal from this RF433 receiver. So this small tiny module is the RF433 ASK type receiver module. So once again here, to receive the radio waves, we are using a whip style antenna, just like whatever we have used for the transmitter, the receiver, similar kind of whip style antenna is available here. So it is only to transmit the power through longer distances. Now coming to the circuit diagram, here this controller's 8 pins are used for controlling 4 different loads. That is, you can see here, if you want to switch on the first switch, 1 on, next one is 1 off, 2 on, 2 off, 3 on, 3 off, 4 on, 4 off, etc. So all the 8 pins connected over here, you can see the insulated wires, they are enameled copper wires, they are going to the switchboard. You can see here there is a switchboard where the front panel is having push button switches, momentary contact switches. So by pressing this, you can actually control this controller. You can give signal to the controller, they are active low, so all the inputs are being pulled up, and whenever you press the button, the controller's GPIO detects a low signal, and based on that low signal, it is going to trigger an RF signal. It is encoded RF, so we are using an algorithm to encode the messages. It's not the Radiohead library, we are using a custom made RF protocol. So using that, we are sending the signal, and the same signal is being decoded by the receiver part. Here we have the receiver. In this receiver also same algorithm is applied, and the encoded message will be received by this particular receiver, and accordingly it switches on and off the loads. So relays are there, and you can connect them to real-time power, and only to indicate whether the relay is on or off, we have given 4 LEDs. Now let us see the thing in action. Let's put back everything here. Let me put back everything into this box. So I'm once again packing the material, so everything can be safely put inside. Right, now we are using this polythene cover only to avoid any short circuit with the battery. Of course nothing is going to happen, everything is insulated, but still to protect the circuit, we are using this insulated plastic cover to protect the circuit. And the whip style antenna comes out here, and also there is a switch button. You can see here, the switch button is only to switch on the power to this battery, because if at all this is on, the controller is going to consume the power, and we have not written in sleep mode. So anyway, there is a 5-volt regulator which keeps on running for all the time. So to save power, what we have done is we have simply used the switch to turn it on or off. Just a minute. Now let's see the things in action. When you switch it on, there is a switch here. When you switch this on, you can see a green LED glowing over here inside, indicating that the transmitter is working. When I switch it off, it will be off. Similarly, when I plug this on to the adapter, so this is the adapter. When I switch this on, you can see there is a green color LED glowing inside, which is feeding the power to the receiver circuit, which is the switchboard. And let me switch on this also. So my transmitter is now on. In one screen I am trying to show you. Please pay attention here. When I press this button, it will be on. The first orange LED will be on. When I press the next button, it will be off. This is on for second, off for second, on for third, off for third, fourth, fourth. So you can control all the 4 appliances from anywhere. Let us say several tens of feet with multiple walls. మీకు మధ్యలో చాలా గోడలు ఉన్నా కూడా multiple walls లో you can transmit this. So we have tested it for several hundreds of feet distance, starting from the road, keeping the receiver inside and keeping the transmitter inside and putting it on the other side road. So like that we have tested for long distances, and this is found to be satisfactory. Thank you. And if you want to order this kit, you can contact iotyantra Technologies, or WhatsApp link is given in the description. Thank you.